reflective construct, your main construct will define the items. So if you are using reflective construct, you can drop an item from that particular scale. Suppose you are using my scale, and my scale is reflective. Since loyalty, your unobserved variable is defining these items, you may drop L1 or L2. There is no difference in the definition of loyalty. Why? Because loyalty is defining these constructs. But in this case, informative construct, your measurement items are defining your main construct. So if you drop one of the item from my scale, then some sense of definition will missing for intimacy. This is clear or not? ये तो हमने डिस्कस किया था ना, डिपेंडेंट क्या है, इंडिपेंडेंट क्या है ना. So in this case, causation is or in this case, the arrow, the explanation, your unobserved variable explain the variance in observed variables. In this case, your observed variables explain the variance in intimacy. Intimacy is dependent on I1, I2, I3. In this case, these items are dependent on loyalty. So if you are using the reflective measurement proposed by any researcher, then you can add, you can subtract items from that scale. But if you are using formative scale used by other researcher, you cannot drop a single item. You have to use that scale as a whole.
So, are these predefined that loyalty will be a reflective construct?
No, ऐसा नहीं. That is up to us.
That is up to the researcher.
So, but generally we don't develop a scale. Why? Because developing a scale is a PhD topic. It takes 4 years to develop a scale. So what we used to do? Other researchers. So just you have to study whether it is a formative scale. In my PhD topic, by mistake I have taken formative scale, used by researcher. पूरा हो गया, उसके बाद हमने डेटा कलेक्ट किया तो हमने देखा ही नहीं था इट इज फॉर्मेटिव, हमने आइटम ड्रॉप कर दिया था, ये कर दिया था, तो एनालिसिस ही नहीं हो पा रही थी. तो बाई चांस आई हैव इंक्लूडेड 4-5 मोर आइटम्स, तो उसमें से निकल के आया. अदरवाइज सो सारी एनालिसिस गलत हो जाती है. सो दैट यू हैव टू रिमेंबर. नेक्स्ट इज we will see. So those 4 are the assumptions for covariance based structural equation modeling. But what happens when these conditions are not satisfied? When these conditions are not satisfied, we use PLS-SEM. So that's why it is when you are developing a theory, you can use PLS-SEM even for a smaller sample size of 20. Even if your data is skewed, it is not randomly distributed. Even if you have outliers in your data set. So in all those cases, you can use PLS-SEM. And when your construct is formative construct, है ना? Then you can use PLS-SEM. So when can you use PLS-SEM? When all the assumptions 1, 2, 3 are not satisfied, and you are using constructs which are one of the construct. If you one or more of the constructs are formative in nature, then you have to use PLS-SEM. This is clear or not? है ना? When your data is not terminally distributed, when there are outliers in your data set, when your sample size is small, then and your constructs are measured in, even if it is reflective and all these three conditions are not satisfied, you have to use PLS-SEM. And all these conditions are satisfied, but your construct is formative in nature, then also you have to use PLS-SEM. This is clear or no?
Yes.
If one of these, so for SB covariance based SEM, this should be satisfied, and this should be satisfied, and this should be satisfied. If one of the conditions are not satisfied, you have to use PLS-SEM. If all the three are satisfied, but your construct is formative, then also you have to use PLS-SEM. So, and basically your CB-SEM is used for theory testing. This is used for testing of theory. And this is used for building of theory building. When you have less research in a particular area and you have to do hypothesis testing, we use PLS-SEM. What is the other difference between CB-SEM? So in CB-SEM, when we will do, so you will see the error term will be included in each of the table. Wherever you have head of the arrow, there one error term will be included. So when we are collecting the data, there will be some error. होगा कि नहीं? So in your covariance based structural equation modeling, error terms will be included.
For this kind, like loyalty, you have put error term, but for trust voltage,
हाँ, so where error term is added, wherever there is an arrow, जहाँ पर भी arrow रहेगा, whether it is observed, हाँ, so you will have error term.
ट्रस्ट में क्यों नहीं है error?
Arrow है क्या इसके पास कोई? नहीं, है ना?
ओके, मतलब एरो का डायरेक्शन के हिसाब से रहेगा।
हाँ, जहाँ पर head of the arrow,
हाँ, हेड ऑफ द
जहाँ पर head of the arrow रहेगा, वहाँ पर error term रहेगा. And in here there will be no error term, है ना? Will not have any error term in here. So that's why your covariance based distribution modeling will give you the global fitness of index. Means your fitness, when you are saying that our model is having a goodness of fit, so that will be